Hello, lovely people. So, here there is part 2 that I've promised you that I will be bringing very soon. So, in physics, now we are moving on to the chapter Kinematics, from which we are going to be discussing important equations and formulas today. So, don't forget to like, share, and subscribe this channel, Study Creatively. So without any further delay, let's dive into this chapter's important equation and formulas. So as I just said, we are going to be starting with the equation of motion of a uniform accelerated motion. So this is what we already did in the previous video, where we are talking about the chapter motion in a straight line. These were the equations that we have to revise and remember for uniformly accelerated motion. Okay, hope you do that. And I hope you watched that part where I've discussed all the important equations and formula of motion in a straight line chapter. Now moving on to kinematics. In kinematics, what do we have? Equation of a trajectory y, which is x tan theta minus g x square upon tu square cos square theta. Time of flight t is equals to tu sine theta upon g. You already know what is u, what is theta, what is g, what is v. Okay, R here is a horizontal range. Horizontal range is going to be find out by the formula u square, which is nothing but your initial velocity sine 2 theta upon g. Okay, so gravitation is g. Then this was about that. Then range will be maximum if theta is 45 degrees. So you have to remember this thing. If your theta is 45 degree, in that case your r is going to be maximum by u square upon g. Then angle of projection is changed from 90 minus theta, then range is going to be u square sine theta upon g. So u square sine theta upon sine 2 theta upon g. Sine 2 theta can be written in this way: sine 2 90 minus theta upon g. G is again here gravitation only. Then u square up sine 2 theta upon g. This was it. Then you have maximum height, which is h. H is going to be find out u square sine square theta upon 2g. Then where the range is maximum, theta is going to be 45 degree. These are the points that you need to remember. Then in that case, h will be find out u square sine square 45 upon 2g. Then u square upon 4g. R max is upon 4. So R max we already talked about in the previous slide, where we are talking about u square upon g. Then u square upon g is R max divided by 4 will give you h. So how did we determine it? Hope you are clear. So then you have this: when a body moves in a circular path with increasing angular velocity when increases, it has two accelerations. Remember, centripetal acceleration, tangential acceleration. How do we find them? This is a representation for centripetal acceleration: a की power c, a base c. And then if I'm going to be talking about tangential acceleration, it is a base t. So a base t is nothing but your tangential acceleration, which is ri. Okay, which is ri. So here I hope you are clear. Resultant acceleration is nothing but a is equals to under root a square c, which is nothing but your centripetal acceleration. Centripetal acceleration is nothing but a base c. V square upon r is equals to rw square. Under root में when you have ac square plus at square, you are going to be saying it is nothing but your formula list. Then